Hello again, guys. We are in 13.2 talking about perpendicular and angle bisectors. So we start here by discussing a perpendicular bisector, and the big thing we want to remember is that a bisector cuts something in half. So if you're bisecting, you're cutting into two congruent or equal parts. So we see that CD is a perpendicular bisector of AB, which means that D is the midpoint of AB, and CD create right angles with AB. I can then connect the lines from A to C and from B to C, and there I form two right triangles, and what we see is we have a shared side, CD, so I can actually prove these triangles congruent based off what we remember from chapter 12, that we have a side angle side congruency here, so that we know CB and CA are also congruent to each other. So Theorem 25, our perpendicular bisector theorem, discusses that if a point is on the perpendicular bisector, so I know that M is my midpoint here, so that makes P on my perpendicular bisector because I also see the right angle, any point on that line, so it doesn't have to be all the way up there at P. I could put a point lower or I could put a point higher, does not matter. It would be equidistant from B to A, the two endpoints of my segment that I've bisected. Now Theorem 26 is the converse of this. I know that if I have a point P that creates PA congruent to PB, that I could drop a line that would have to hit my AB line perpendicularly, but when I drop that line, I know that that is a bisector since I knew that these lengths were congruent to begin with. Make sure you've worked through section 1 on Pearson and then try the got it. Come back when you think you have your answer. So when I start evaluating these two triangles, I see that SQ is perpendicular to PR, so I know it's perpendicular. Then I see that PS is congruent with SR, so I know that it's a bisector. So this means this line is my perpendicular bisector, which also means that PQ will be congruent to RQ. So I can start by setting these two binomial expressions equal to each other. So we set our two binomial expressions equal to each other. I subtract 3n from both sides, which gives me my 2n. I then add 7 to both sides, which gives me a positive 6 equal to 2n. Then I divide by 2 to get n by itself and find that n is 3. But we're not done yet because we're not trying to find n, we're trying to find QR. So to find QR, I need to plug in the value for n. So that would be a 3 in there, which would be 5 times 3 gives me 15, minus 7 gives me a final answer of 8. So when we start here, we're being asked, what is the relationship between MB and JK? Well, MB is my vertical line here. JK is my horizontal, like the base of my triangle. So again, I see that we are perpendicular and that we have B being the midpoint, which means that we are bisecting. So we know that MB is the perpendicular bisector of JK. Just like we did in the last problem, go ahead and do the math to solve for the length of JM. Just like on that last problem, I set my two lengths, my JM and my MK, equal to each other. I then started by adding 18 to both sides so that I could then subtract 3x and combine all my like terms of my variables on the left side. I got 6x is equal to 18. I divided by 6 and got that x was 3. I plug it back into either one of these since I know that they'll be congruent. Easiest thing to do is plug it in right over here. 3 times 3 is 9, so that will be the length of JM. Our got it relates to problem 2, so please make sure that you've worked through problem 2 in Pearson and then come back for the got it. So we want to answer, can the t-shirt stand be equidistant from the paddle boats and the spaceship chute? So what are the possible locations? Where could it go? So go ahead, think about, and maybe even sketch out if you want. We've got paddle boats, spaceship chute, and we want the t-shirt stand to be equidistant from the two of these. Alright, so what we want to do is connect the line that is between our paddle boats and spaceship chute so that we can find the bisector and more so the perpendicular bisector. So I can measure this distance and see that it's about 11.5 on the ruler that I'm using. So half of that would be 5.75. So if I go there and do a perpendicular line, I can either go that direction or I can go the other direction since I know that this is my midpoint and these are perpendicular. Anywhere on this line would be equidistant from the paddle boats and the spaceship chute. So B is asking, can we place the t-shirt stand so it's equidistant from paddle boats, spaceship chute, and the rolling coaster? So we already know that if it's on this perpendicular bisector that we drew, it will be equidistant from the paddle boats and the spaceship chute. Now if I want it to be equidistant from the spaceship chute and the roller coaster, then I need to again connect those two things, find the midpoint, which again I measured and I cut it in half to find the midpoint, and then I drew this line perpendicular to that connecting line from RS. So now we've got line L as it was in problem 2. So where line L meets with the perpendicular bisector that I drew from PS, this point right here will be equidistant from the paddle boats, the spaceship chute, and the rolling coaster, and that point actually has a special name that we will get to later on in our chapter. I could do the same thing connecting the rolling coaster with the paddle boats with that perpendicular bisector, and again it's the point where they all meet. So this is the point of all my perpendicular bisectors intersecting each other. And there are the answers written out if you are still at all confused. So in our extra problem here, not in Pearson, but it is in your notes, we're being asked, is St. Vincent's Hospital equidistant from the Village Kids Nursery School and the Legacy School? So we've got the Village Kids Nursery School and the Legacy School. So if I connect these together, then I want to find the bisector for those. So if you want to be accurate, you should measure. So we can pull this down here. I'll just start at the 15 and do some easy math to figure out what the actual length is. Alright, so I moved my ruler to actually work with me here. So I see the distance between them on this ruler is 4.5, so I cut that in half and go to 2.25. So this is indicating where my midpoint is going to be. So then I want to make the perpendicular bisector. So I just draw that line perpendicular. And I look for, is St. Vincent's Hospital on the perpendicular bisector? It is not. So we see that our answer is no, St. Vincent's is not on the bisector, so it's not equidistant. We see it would actually be closer to nursery school than it is to Legacy School. So on your notes, draw this out really quick. If you have a point H for home and a point S for school, how could you figure out all the points that are directly between them? Alright, I took this one step further and I went ahead and grabbed a screenshot of the map of our Worthington area. So here we go, there's Phoenix. You could do it from Kilbourne or wherever, but I'm going to make Phoenix my point S. And then for the sake of our problem right here, I'm just going to say that my home is right here, which it's not. I do not live on that intersection. Near there, but not quite. So we want to first start by connecting these lines. Make these the base line that you are dealing with. Then we have to start by finding the bisector. So again, to bisect something, we need to find the middle point. Alright, so I've got my line connecting H to S. And then I measure this to find the bisector point. So I use my ruler and see that that's about 14. So I see 7 would be my bisector point. I'm going to get rid of the ruler now. Now don't pay attention to this degree measure. That is how rotated the entire thing is. And my line to HS is not horizontal, so I know it's going to have to be at an angle. But I line this up with the same angle that HS has. I see that the line going straight through will be that perpendicular line. So I can then draw a line. I'm just going to go both directions. So I'll draw a line there, and then I'll draw a line right there. And now I can get rid of my protractor. And now I see that any point on this line is equidistant from home and school. So if I wanted to find a point on a road that is dead equidistant between school and home, I could choose right here on Bridewater, or I could choose down here on Smoky as it starts to go up, or even somewhere way over here. It's far away, but it would be equidistant from home to school. Now, of course, that's talking about straight line distances, not distances driving on the road. But once we have that perpendicular bisector line, we know any point on that line is equidistant from H to S. And there is the process written out if you need to see that. So now we're going to start talking about angle bisectors, and we see this special relationship here dealing with the distances between a point on an angle bisector and points on the larger angle that it is bisecting. So if we choose a point on the angle bisector, say we have point D here, because AD is my bisector, it's cutting into two congruent angles, and then I draw a line from D out to my ray AC, and then a line from D out to ray AB, paying attention that these have to be perpendicular when they meet the rays. These distances from D to my ray and D to my other ray, these two distances will be congruent with each other, and they're also the shortest distance from the bisector to the ray, because if I go at not a 90-degree angle, it will be a longer distance to travel. So here we see that restated again in our theorem 27, the angle bisector theorem. See, if QS is the angle bisector, and I have lines SP that is perpendicular to QP, SR that's perpendicular to QR, then my distances from SP and SR will be congruent with each other. Now likewise, the converse of the angle bisector theorem is saying that if I have a point in my angle that has two lengths perpendicular to the rays that are congruent to each other, then that point must lie on the angle bisector. Please make sure you've worked through the next section of Pearson and come back when you have solved the got it. So pause the video until you have an answer for the value of x and when you know what the length FB is. I know that these two segments will be congruent to each other, so I set up an equation. I use algebra to solve. I find out that x is equal to 3, and when I plug that back in here, I get 6 times 3 is 18, plus 3 more gives me a final answer of 21. If I plug in the 3 for FD, I should also get the same answer, and that's how we can check our work. We should be able to get the same lengths for our two segments right here. This problem has us starting by kind of having to apply what we know about angle bisectors. I see that I have a point L here, and that point has two congruent segments coming off of it that are both perpendicular to my rays. So what I know is that makes LH the perpendicular, not perpendicular, but the angle bisector for the angle KHF. So that tells me that KHL and LHF will be congruent to each other. So go ahead, set up the work to solve that, and then come back when you have the measures for both of these angles they're asking for. So when I solve out the algebra, I get that y is equal to 9. When I plug that back in for my variable, 6 times 9 gives me 54 for KHL, and then if I want angle FHL, it should be congruent. So again, I can plug in 9, I can do 4 times 9 and then add 18 more and still get 54. Pause the video and try number 6 on your own. Come back when you've got your answer. So I see that these two angles are congruent to each other, so that tells me that JL is an angle bisector, and since these segments are perpendicular, I know that x plus 5 will be equal to 2x minus 7, set them equal, use algebra to solve, find that x is 12. When I plug it back in to both of these, I find that both of their lengths are 17. I am quickly running out of time, so please pause the video, try 7, 8, and 9, and then come back to get the answers for all of those. Because AC and BD are perpendicular, so AC is the perpendicular bisector of BD, I then see the special relationship that I have between AD and AB, and the special relationship between DC and BC. We are going to go ahead and end the lesson there, so please make sure everything makes sense, and let me know if you have any issues or concerns about this material, and I will see you guys in class. Have a wonderful day.